Hello everyone. This is our second lecture on part design. Last time we have covered the PowerPoint slides until the end of slide number 17. So now it's time to start slide number 18 on loft and cut-loft. So loft is for connecting different basically profiles, different shapes together and creating objects. Okay, so in that aspect it is different than sweep, extrude, revolve, or anything like that. Actually, it's the most difficult one out of all different commands in part design. And first you might wonder, where would you use that? Where in real life you would see lofts? And there are lots of places, like the head of a flat screwdriver. If you pay attention, the screwdriver basically has a circular section in the shaft, and then when it goes to the flat head, then the cross section becomes what? A narrow rectangle, right? So flat head screwdriver, if you take a look at the head, right? So clearly you see, if I keep cutting this object, I get circle, 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 and then after some point I get what? I get different narrow rectangles, right? So that's one of the places that you would get a loft or fuselage of an airplane. Basically, if you cut the fuselage at different locations with vertical planes, you will get different circles and different ellipses. Okay, so that can also be a loft. The wing itself, the profile, the basically SP-lines that you have here, the couple of SP-lines, I mentioned that the airfoil is a couple of SP-lines, one on the top, one on the bottom. The airfoil that you have here at the tip of the wing is basically different than the one at the root of the wing. Different sizes. So here you have to have one profile here, one profile there, and then connect them with this loft method. So there are lots of things. Your human body, right? If you cut a human body with a lot of horizontal planes, right? Something like an MRI, basically, you will get different sections of different shapes, ventilation canals that you connect circles to rectangles and so on. So this is actually very, very common in real life. And that's what I want to show you how to make in SolidWorks. So let's talk about that. So here we go and create a new part. And then on one plane, I draw one profile. Okay, let's say here on the front plane, I go and draw a centered rectangle like that. And then on a plane parallel to the front, right, so I give it some offset, let's say 4 inches or something like that. And then on this one, I will draw a complete different shape, a circle, something like this. And now my goal is to create an object that goes from a rectangular section to a circular section. So for that, I use the lofted boss base, and then I choose the profiles. So this is one of them, this is one of them, and it gives me a preview of the shape, okay, which you can clearly see here. And this preview is actually quite nice. Okay, so if I OK that, I would get a loft. It's kind of also might look like a, if I make it longer and different shape, might look like a basically salt shaker. So now how is a loft created? Well, the way to create a loft is basically, if I go back and edit that, there are 2 points, we call them closing points, that you see here shown with green. one on each of the profiles, you connect them with a straight line, and then keep going around the profiles, and then connect what? The next point to the next, the next point to the next, and keep connecting with lines until the surface is generated. Okay, now, two important things. One, should we always connect with lines? No, I'll talk about that. You can connect all of these points together with something other than line, and you call those guide curves. So you can define guide curves to create connecting entities. And the other thing is, how does SolidWorks determine which two other points to connect to each other? Okay, what do I mean by that? So let me show you. So what is we call coupling method? How do you connect 2 points on these two profiles together? How do you know which 2 points belong together to connect? So here, the first point are determined typically by the points you click on when you select the sketches, but the next points are determined by different ways. One of the most common ways that always works, we call it the ratio method. So the ratio is like this. If I measure the circumference of this rectangle and I call it L1, and if I measure the circumference of the circle and call it L2, then let's say the next 2 points that are connected are this one and this one. Okay, so I connect them also with a line. Well, how do I know that these 2 points belong together? So the way to do it is this. If the distance between the new points on the first profile and the initial point, which we call them closing points, so these two guys, we call them what? Closing points. If the distance between the new point and the closing point, I call it what? Whatever you want to call it, let's say P1. Then P1 I will decide. So let's say I say 2% of L1. So I set P1 over L1 to be what? To 2%. So I say, or 1%. So I say go forward 1% of the total circumference and get your new point on profile 1. Now how would you do it for profile 2? The same thing. You go ahead 1%, but 1% of what? 1% of L2. So if the length of this arc here, I call it P2, the P2 over L2 should also be what? 1%. So that means P1 and P2 are not equal because L1 and L2 are different. Okay, so I go forward 1% of the circumference in this one and then 1% of the circumference in the other one. And then I connect. Then I go to 2%, 3%, 4%, and keep connecting with the guide curve, which in this case is a line. If you don't say anything about guide curve, SolidWorks default is a line. And then keeps connecting all with line, line, line until what? The surface is generated. So this is called ratio coupling. Okay, so these terminologies that I'm telling you, ratio coupling and then closing points, these are good for you to know. Okay, so this is for creating a simple loft. Now, two important things. One, if these closing points that are chosen in the beginning are not right in front of each other or in a good orientation, then you will get a twist. So if I just click on this point and grab it and move it elsewhere, right? Move it, let's say here. Look now. You would get a what? You would get a twist. So if you ever get a twist in your loft, the reason is the closing points are what? Not in front of each other, okay? The initial closing points are not appropriate. So you need to go back, and you can see now here, and you need to make sure that they are what? Properly in front of each other, right? So this corner point to like this diagonal thing, this one comes here. Now here it is adding more points for you to figure out, but If you do it properly, then you can get rid of the twist. Okay, so this, pay attention, that very important. Still has a little bit of twist on the top, but you can fix that. So moving the closing points, you can twist or untwist the feature. The other thing that I mentioned are the guide curves. Okay, if you don't want to connect with lines, you can use guide curves, but guide curves, you have to define them ahead of time. So here I delete the loft, not the sketches, and now I need a couple of guide curves. So this is what I would do. I go on a plane that is perpendicular to both of these sketch planes, let's say right plane here, and then on that I will draw a guide curve. Let's say I use an S-line. The important thing about this S-line or any other guide curve is it has to be coincident with both of the profiles. If it does not coincide with these profiles, you see here I can see this coincidence symbol, this yellow window with two lines intersecting at a point. Okay, that's the symbol of coincidence. If that does not happen between guiding curves and the profiles, then you will get error. So if you start something like here, this is not going to work, okay, because it does not coincide with the profiles. So here I do something a little bit different, and then if you want one for the bottom two, another point is it has to be created in a separate sketch. Okay, so you cannot have that in the same sketch as the first guide curve. So you can add guide curves. If not, SolidWorks would use lines. You can even add thin feature. The other important thing I wanted to mention is guide curves and profile curves have to be defined in separate sketches. The profiles have to be in separate sketches, and the guide curves. None of these four things, right here I'm using two profiles and two guide curves, none of them is in the same sketch. So basically you need to have what? 4 sketches. Otherwise it's not going to work. So here again I choose the right plane, I go to sketch, and I draw another guide curve. Let's say here I use a 3-point arc instead. Okay, so 4 separate sketches. Now let's see if it allows me to use them. So I use the loft, and you see here, by the way, you can provide thin feature. So for the profiles, I choose sketch 1 and then sketch 2, and then for guide curves I choose sketch 3 and sketch 4. And you clearly see that now the points are not connected by straight lines anymore. They are connected on the top by the top curve, on the bottom by the bottom curve. So you get it way more complicated. And again, you can provide even what? Wall thickness. Okay. So you can have a shape like this if you want to. Okay, very complicated. So loft, as I said, is the most powerful command, and it allows you to create very complicated objects. So just keep that in mind. And then you can do cut-lofts, right? So you can have 2 different profiles and cut a loft out of something. So it's exact same thing as this one, just hollow out the material. Another very useful feature is mirror. So if you have half of something, if you have symmetric objects, you can always basically mirror it with respect to a plane and get the other half. It's very useful. So in this case, let's say I have this object and I want the mirror image of that with respect to this plane. So I click on the mirror command. It says, what is it that you want to basically mirror? Is it a feature? Is it a face, or what? Actually, for me, it's a body. So I want to basically get this whole thing. Actually, in this case, since I can call it also a feature, so I would call it the feature because that's a single feature here. And then what is the face to mirror about? And I say that's this face, and there we go. Okay, so mirror can be a really useful command. Okay, then we have linear and circular patterns, using which you can repeat a feature or a body along radial or linear directions. So let me show you those. So for linear, or we call it matrix pattern, let's say here you have this box, and then on the top of that you make an object, let's say a small cylinder. And now you want to repeat this on the surface in a matrix manner. So in one direction several, in the other direction several, and make a matrix of that. So you use the linear pattern here. And then it says, what is it that you want to repeat? What feature? You say this guy here. And then, okay, it says along which direction first? Direction 1, you say along this edge. Then it says how many and with what spacing. So you say, let's say I want 5 of that with the spacing of 1.5 inches. And then I also want along direction 2, which is this one. And along that, I also want with some, let's say 1.5 as well, 3. And if the direction is wrong, then you click on these reverse directions and you reverse it, and there we go. You got 15 of that. Okay, so this is very, very useful command. You can also do a basically circular pattern. So for objects with axes of symmetry, that can be really useful. Let me show you that as well here. So let's say you go to the front plane and then draw something. Like that. And then like this one. And I use an axis of symmetry here. So I choose these 2 lines and then this axis and choose symmetry. So it means those 2 lines with respect to this axis are symmetric. Like that. Then I trim it off. Then I get out and extrude. Okay, right? And then I go to the same front plane, and here I'm just making you a very rough gear. Of course, this is not a perfect gear. We'll talk about it. Gears are not as easy as just drawing something the way I did. They are way more complicated, especially the tooth profile. So again, here I use a symmetry line. So I'm using 3-point arcs to draw the teeth of the gear. They are not like that, absolutely not. But just to make life simple for now. I guess I need to redo it. Okay, and then I mirror this with respect to this axis. And then I connect. And then I use this one, convert entity that to get this black curve, and then trim it off. So I just want the profile of the tooth to remain, which is this guy right now. And now I will extrude this, get like one tooth. Again, this is very rough. And now I want to create the rest of them, the rest of the teeth. So I choose this feature, and then I go under circular pattern. And it says in which direction. So if I choose the face, it can use the face to go around the face. Or if I want the axis, I go here. Since I already have a symmetrical object, I can see the axis of it. I go under eyes and say show temporary axis. Okay, and then it allows me to see the axis of symmetry of the object. Then I provide the number of teeth, and then I say equal spacing. How many of them here? Let's say I want probably 30 or less, actually. Say 24. There we go. I got the rough gear. Right? So that's how I can use a circular pattern. Then there are, so these are the main things. But there are some other stuff that could be quite interesting to you, including a wrap, a rib, a dome, scale and deform, free flex and freeform, intersect and split. Okay, so there are several of them, and let me go over these more advanced features. So one of them is rib, and rib is for basically creating a supportive structure between two planes that are typically perpendicular to each other. So this is used typically for reinforcement. And when you want to create the rib, you just need the silhouette sketch of the rib, and then it will create it. So it's a simple extrude, but you can do it way simpler than doing an extrude. So let me show you how you can make a rib very simply. So I will create an L-shaped structure here, and then I will connect them together. Like that. And now I want to provide a reinforcement between these two. So first, I want it to be in the middle. So I need to have a plane in the middle here on which I draw the profile of the rib. And I don't have that because I started on the right plane. And so this is basically 5 inches. So I need to move forward from the right plane 2.5 inches. So I need an offset plane. Or I can select the right plane, this front plane, and then use middle command, right? So I need a specialized, customized plane. So here I choose the right plane, and then I choose this plane. And then it gives me the mid plane option. So that's a good plane to start on. And here I'll just draw a line connecting this vertical edge to this horizontal edge. That's all. I'm not going to do a closed sketch as you did for a extrude, right? For an extrude, you always needed a closed sketch, not here. So I just make one single line. Okay, and then I choose this line, and then I go to the rib command here. And then it says, okay, in which direction? Say, of course, basically parallel to or perpendicular to that plane. How wide do you want it? Okay, and do you want it on one side of it, the other side, or mid-plane? So I use mid-plane. You can even give it draft angle or anything. Let's say that's good enough for me, and then okay that. Okay, so now here it says it does not intersect with the model. Why? As you can see, that's another common error that you see. So this arrow is outward. You have to click on it and make it in. And there we go. So I got a structure, a rib, that reinforces the two walls and connect them together. Okay, so that's about the rib. We have scale and deform. We have wrap. This wrap is a very interesting feature that you can basically wrap a sketch around a curved face and then emboss or deboss it, or just put it as a pure text. So remember I said that when you want to write something or make extrusion or cut extrude, you cannot start a sketch on a curved surface. You always need to start your sketches on flat surfaces. So the only way to get around it and put an extrude or a cut extrude on a curved surface is using the wrap command, which is quite an interesting thing. Okay, so let me show you this because it is an advanced and exceptional feature in SolidWorks. So let's say you have a cylindrical object and then on which you want to put the logo of your company, right? Like that. And now, well, how would you create an extrude on this or cut extrude? Let's say I want to cut extrude. So some people might say, well, I just create a plane tangent to the surface and then I draw a sketch on it and then extrude it. Well, it's not going to give you exactly what you want. Let me show you. So first, let's create a plane that is tangent to the surface but parallel to the right plane. So I go here and I will actually let me give it a little bit offset, so I'm not going to make it pure tangent. So I go to the right plane and then I give it enough of offset like that. Then in this plane I write something. Still bigger. Something like that, right? And now I want to create a 3D effect from this, right? So I want to extrude it onto the surface or cut it onto the surface. So some of you might say, well, extrude it in the reverse direction, and instead of just going a fixed amount, just say up to surface. And for surface, choose this surface. And then if you do it, guess what? You have 3D, right? But look at that, right? It's gonna be a funny extrusion. Or if you do cut extrude, it's still gonna be a cut extrude, and the different letters have different depth of the cut. So it's not going to be exactly a uniform thickness for all of the letters, and so it is going to be quite a weird thing. So the way to get around it, as I said, is not to extrude that really, or cut extrude that onto the surface. The way to do it is using the wrap feature. Okay, and for the wrap feature, the best way is to make sure this plane is tangent to the cylindrical surface. So here, this plane was not completely tangent. You can see it from the top view, right? But I can make it tangent if I want to. So instead of just giving it a pure offset from the right plane, I now define a second reference and say my second reference is this. Okay, and get rid of this offset. So let's see if I can redo that. So parallel to that, and then I want this also as my reference. There we go. So now if you look at it from the top, it's parallel to the right plane, yet tangent to the cylindrical surface. And I write my sketch, write my logo, whatever it is, on this. And now let's see if we can use the wrap feature here, and it says, okay, select the sketch plane. Let's see if I directly use the sketch and then go to wrap, whether it works. Yes. Then it says, okay, what do you want? Do you want to emboss it, which means create an extrude on it? Do you want to deboss it, which cuts it? Or do you want to just scribe it on? So scribe does not give it any 3D feature, okay? It's just like carving it with almost zero thickness. So I recommend you do emboss or deboss. Let's say I want to emboss that. On what surface? On this surface, and then look. Here we go. Uniform thickness, how much was it? You define it to be 0.1 inch. You can make them all bigger. Let's say 0.2 inches. Right? So that is the right way to go about it. Or if you want to cut out, then you say, no, actually deboss it for me. Cut it inside. There we go. Yes, uniform thickness of cut. So that's what I really like about this command wrap. So another command that I like is a dome command, which you can create a spherical surface on the top of a circular face. Where would you use it in real life? Well, for example, in our campus, you can see the one on the STEM building. Or more common than that is the end of a screwdriver, right? It's not typically as round as this, but the end of the handle of a screwdriver can be quite similar to that, right? So here, can make something on the top of this, and the dome command is not here. You have to go under insert and features. Some of the part design commands are here in this area. Not all of them are available there. So dome is here, you can select it, you choose the surface, and then you create the amount of what? The bulge, basically, right? How much of radius do you want? Okay, so it's not necessarily a hemisphere. And then there we go. Correct? So this can be really useful for creating basically the end of a screwdriver. Right? Let me make this a little bigger. So that's about dome. The other interesting stuff we have are called flex and freeform. These are again more advanced for deforming an object and creating more complicated features. So let me show you those. So let's say flex, which is quite interesting. Let me show you an example of the flex. So I will create a rectangle and then make it a cube. Right? And then again, those commands are not here. You have to go under insert features to get access to them. So one of them is flex, and here you basically deform the material using different ways of deforming. And these guys are what you probably have seen or will see in your solid mechanics course: bending it, twisting it, tapering it, stretching it, and so on. The most interesting one to me is the twisting. So you twist the object, and then it is asking you to provide basically the amount of twist, right? Okay, so you can keep going and twisting it. Now it is twisting about the z-axis and giving you a very complicated object like that. Okay, so that's quite interesting by itself. Or you can bend the material, right? So instead of twisting, say I want to bend it, and then you can bend it along different directions. Here the bending is happening on the YZ plane, right? You can bend it along different directions, and then you can change the angle of the bending and then the radius. And it again something different. So these are quite interesting commands. The other one, that is Freeform. So here you choose a bunch of control points and basically move the control points and deform the surface of an object here. So that's quite interesting for itself. So you need to add curves, you need to add control points, and then you need to move them around to deform the surface. Let me see if I can get you an example of that. So insert features, then we go under Freeform. Which surface do you want to deform? This top surface. Then it gives you a mesh on that surface and the boundaries, and then it says how do you want the boundaries to react. So you say I want them to be movable. I want this to be movable. I want all of the points on these boundaries to be movable, whether movable in general or just tangent to the edge, okay, or follow a specific curvature. So these are your boundaries. You allow them to move, and then you want to have it through control points. And so now you say I want to add curves along which I define some control points. Okay, so you can say flip direction to make them basically align the z-axis instead of the x one. Let's say I want something along this line, right? Maybe here and then here. Then you can add points on these curves, right? So I can have 1 point here, 1 point there, and then here, 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 then here, here, here. Okay, and each one of these points you should be allowed to move that point. Okay, so as you can see here, you can add again curves along which you define control points. You add control points, and then you can change the number of mesh elements to make the deformation finer or coarser. So the more mesh elements, the more small squares that you have, the finer the deformation will be. If there are a few of them, then once you move one thing, the rest of the surface will move with it. Once you make it smaller, then once you do a change locally, it's not going to affect the rest of the surface, okay? So that's what it is. And let's say here, if I come to this point, correct, and you see these arrows, so that's this control point. Let's see if I can get it to move. There we go. So you click on it, then it shows the triad on it, and now along any of these axes you can move the control points. Right? Something like that. Then you can come here, move this a little bit along Z, and you can come here. If you add any control point, you click on it and then move it. right? So it is actually very complicated. You really need to know what you're doing. Otherwise, it can create a very weird result. And there we go. Look at that. Okay, very complicated thing. Again, you need to really know where you're putting your control points, how much you're moving it, what mesh density you have, and so on and so forth. Otherwise, it can be completely counterproductive. The other thing is the scale command, and you can scale any object uniformly along all three axes with respect to a point, or you can scale it differently along different axes and create not only resizing, also a shear effect. So let's say here I have this object, and then I'm gonna scale it for you. So this is the original object that I just made, and then the scale is not among any of these commands, so I need to go under Insert, Feature, and then scale it. And by default, SolidWorks asks you to do uniform, but you can uncheck this and do it non-uniform. If the number is less than 1, you make it smaller. More than 1, you make it bigger. And about which point, you can choose any point. You can choose origin or centroid. My recommendation is always go with centroid. And if you want non-uniform, then you can provide different numbers for different axes. So here I'm not changing Z, I'm not changing the thickness, I'm making the height 1.5 times bigger, and I'm making the width of the part 2 times bigger. Okay, and there we go, look. Yes? So this is non-uniform scaling. If you made it uniform, in all directions, the number will be the same. Now, the other more advanced commands that we have are intersect and split. Very, very useful commands, extremely useful, especially when you have a part and you designed it and now you want to manufacture it, but you don't want to manufacture it in one single piece. You want to cut it in several pieces and then manufacture each one separately and then put them back together. So this can be really helpful. For example, one of the things I remember myself using this was when we were making the campus miniature model, that big table you see in the STEM building. And a few of the buildings were too big that we could not put them on the printer. So they were too big for the size of the printer we had. And what I did, I guess like T1 and T2 or the gym, I chopped them in half using this method, and we printed each one, and then we put them back together, glued them back together. So let me show you this. As I said, this is extremely useful command. So you can cut a part using a plane or a surface, and either just split it or just look at the intersection of the plane with the object and just get an intersection curve. But I guess the more interesting thing is to split the object. So here, let's say I define a plane. So I go on reference geometry and say I want a plane passing through this edge. Okay, and I also choose this plane too, if it allows me to, in some angle. No, it does not like it, so maybe I choose these two guys. Let's see, so I choose that plane and this plane, and then I use the plane that cuts the angle between them in half, like that. Okay, and I can even give it an offset. If I don't want this directly, I will create an offset version of that. Like this, and then I use this plane 2 to cut the object in 2 pieces. So I go here under Insert, and then again the split is not here, so I have to go under Insert Features, and then I say I want to split the part using that plane. It says, what is your cutting surface? I say this guy, and then I say cut it. So now it gives me what? A part 1 and what? A part 2. And then I say give them a name, auto-assign names. Before you can do the split, that's another important thing. Before you can do the split, if you just saw, it gave me an error. You have to have your part saved. If you don't have your part saved, it's not going to allow to split it, okay? So first I need to save this somewhere, right? Now I can split. Another thing I remember for split were those campus topographies. So if you see the topography of the campus in that campus miniature model table, right, it has ups and downs. So I created the surface of that. I got the file from Google Earth. I give it thickness, and now that is too big, 8 foot by 8 foot. I cannot print that, so I chopped it into 25 pieces, 25 smaller pieces, and we printed each piece on the big printer we have in the lab. So I used this guy several times, and it has real-life applications a lot. So here we go. Now I should be able to split. I use this one, I cut, I choose both of them to be saved, I auto-assign names, and then I OK that. And when you do, SolidWorks will give you 2 parts and then save them for you. So this is one of them. This is the original one, which is a split, but also, look, if I close this, it gives me the 2 other chops. So this is one of the chops that it is called, I guess, body 2 and save, and this is the other one, body 1. Okay, so this split command is extremely useful, as I said. The intersect command just gives you the curve and intersection. It's not really splitting, so I'm not going to go over that. It just gives you an intersection curve. The other command that can make complicated surfaces for you and complicated objects is Boolean operations. So Boolean operations, you have 2 objects, and then you can use a union or add, so create an object by adding them. You can subtract one from the other, or you can use common, which is basically the intersection. Okay, and these are really useful for very complicated objects. Probably if you want an object this simple, you don't need a Boolean operation. You just make the cube, draw this sketch, and cut extrude it. But when it comes to complicated objects, then this Boolean operation can be quite useful. And you might wonder where in real life a Boolean operation can give me something that is easier than extrude and cut extrude. And one example is inside the wing of an airplane. So if you look inside the wing, so airplane, wing, ribs, and spars. So inside the wings of an airplane, there are internal structures. And these internal structures, let's see, here actually, that can be better. Some of them are parallel to the airfoil from the root where the wing is attached to the fuselage to the tip. So these structures that are repeated along the span of the wing, we call them ribs. And then there are these longitudinal structures, which kind of look like a plate. And there could be several of them. And we call these guys what? Spars, okay? And the spar is quite an interesting thing, because if you want to create a spar, it looks like it's a simple extrude, but it's not. First of all, if you look at the profile of the spar, it's not simple rectangle. Why? The 2 sides of it are straight lines, but the top of it and the bottom of it are actually what? The part of this S-lines. So it is a complicated shape, 2 straight edges and 2 segments of S-lines. And when you extrude it, even if you have this sketch, when you extrude it, it's not going to be a simple extrude. It has a draft angle. And the draft angle is not even that simple. Why do you have draft angle? Because the root airfoil is bigger than the tip airfoil. Okay, so it has a weird kind of draft angle too. So if you want to make a spar, instead of creating this profile and then giving it an extrude and then finding the draft angle on both directions and finding all of that, which takes quite much of time, the best way is this. If you have the wing, just the skin of the wing, all you need is to create basically a big plate which cuts the wing, and then see which part belongs to both of them. Use the common operator or intersection. And the part that belongs to both is a spar. Let me show you that actually here, because it's a good practice for multi-section and to create a spar. Actually, you can also do the ribs as well, right? So for the ribs, you need a bunch of planes that are parallel to the profile, to the airfoil, and cut those planes with the wing, and those will give you ribs. So you can do ribs and spars with Boolean operators. Way easier than you do it with extrude, cut extrude, draft angle, and so on. So here, let's first make a very simplistic wing. So I go to this front plane, and then I use a couple of splines to create the root profile, airfoil, and then the tip profile. So let's say this is the top part. And this is the bottom part. Okay. So this is the root that is bigger. Now I want something with offset on the tip. So I go and parallel to the front plane, I create a plane with offset. Okay, long offset, let's say 12 inches, or even better, 20 inches here. It's just scale down in the this direction or opposite, doesn't matter. And now on this one, I will create a smaller or a bigger version of that. Okay, so what I do is I project this guy onto this plane using convert entity, and now I'm gonna scale it up or down. Okay, so I choose these guys, and then I use the scale command, which is here. Then I scale everything with respect to this leading point, and I provide a bigger airfoil like that. Okay, so now I say that the big one is the root, and the smaller one is the tip. Okay, so I have two different airfoils. And now I connect them using a multi-section loft. So I choose this one. Then I choose this one. And it gives me a wing. Make sure that the endpoints are connected properly and no twist. Okay, so let's say that is a wing. Okay. And now what I need is I need to bring another part, insert a part, okay, and then I apply a Boolean operation. So the important thing is, first, when you do Boolean operation, you cannot do Boolean operation between two features that both belong to the same part. So here I only have one part, part 12, and if this loft and then this plane plates that I would like to intersect with the wing, if both of those are features belonging to the same part, then I cannot apply a Boolean operation between them. In order to be able to do a Boolean operation, what you need is two different parts. So the wing should belong to one part, and then that plate should belong to another part. Again, if both features belong to the same part, you cannot do Boolean operation. Boolean operation is only applicable to different part bodies, not different features of the same part. So here I need to insert another part first. So I go under insert, and then I insert a part. Now here it is asking me to insert it, so I have to have that part made, okay, ahead of time, but I haven't. So first, let me save this. or 12, or I can call it wing. Let's give it a meaningful name. So wing skin. And then remember that this one is made on the front plane and forward of that. Okay, so now this is what I would do. I will create a new part where I would go on the front plane, or actually the top plane, and then I draw a rectangle. Well, actually, no, I need to go on the front plane. Front plane, sketch, make a narrow big rectangle. And then I will extrude this big enough that, so not only I go in this direction, I also go backwards too a few inches. And give it a different color, although we'll work on the color later on, but let's say here, and then I save this and I just call it plate. So now my job is to come back here, insert that plate, and then apply a Boolean operation. So I say insert part, and then I want plate, yes. Then you can here basically put the plate at where you want. Oh. Right, like that. Okay. So now actually it's not perfectly done because this is way bigger, way upper, where it's way higher than the wing, so it's not going to intersect. Okay. So you have to move it. So let's see if I can apply locate and locate this. So I say, well, the distance between this one and then the top plane. So here it made them coincident. I don't want it coincident. I want them at an offset. Flip direction. Okay, so you can always use locate to exactly put it where you want. Right, so now it is in a good position. And as you can see, again, the loft belongs to one object, and then this plate, this object, this plate here, belongs to another part. But you see there are two yellow parts. These are two different parts. Now I should be able to go under insert and then features and then Boolean operation, which here actually we call it combine. But combine gives you to combine, subtract, or do what? Common. It says which two bodies to do an intersection or common. You say these two guys. And look, there we go. Right? So again, as you can see, the profile is not perfectly rectangular. You clearly see that. An SP-line here, an SP-line here, straight, straight. And when you look at it from the side, also there is a draft angle in different directions, differently. So creating this is way easier to be done by Boolean operations than extrude and cut extrude. Now let me get rid of this. So I want to do something different this time. I right click on this and actually let's see if I can locate it again. So let me bring it one more time, just practice. So I insert again a part. I bring this guy in, but this time I want to be able to rotate it. Okay, so let's for now just keep it here, but yes, it allows me to locate the part. So I'll try to rotate it 90 degrees and make this one to be parallel to the front plane here. That's good enough. So we enter that, and then I also want this one to, with respect to the right plane of that, to be parallel, and then some offset, flip it, and do it such that it cuts that, like this. Okay, and guess what happens if I now do an intersection? Yes, I will get a rib instead of a spar, right? So I do common again, and this one, and look, I get a rib. So I can easily do what? Ribs and spars using Boolean operations. Okay, so maybe instead of these pictures, I want to add pictures for you of what? Ribs and spars. Okay, so here I have added for you a more meaningful picture, more useful picture. Now that we have seen all different ways to create parts, modify parts, let's talk a little bit about the appearance of the part as well. So you can change the color of the part, the transparency of the part, the texture of the part, and everything in SolidWorks, and you can also apply material. So let's say I have this part here, right? And let me close this, close that, and open the wing again. So if I want to change this shape, I simply, the color, I just right click on the wing and then go to what? Appearance, or I can access it from here too. Right, so I click here to bring the appearance, and now I can change the color to anything that I want. Right, I can change the RGB, red, green, blue components. I can provide HSV if I want, hue, saturation, and value. I guess RGB is good for our case. And remember that if you do it this way, then the entire part will be the same color. Sometimes you do not want all of the part to be the same color. You want each surface to be colored differently. So instead of making the whole loft go yellow, I right click on the surface that I want and then choose appearance, and then I use face. I don't use body or loft, I choose face. Then let's say I make this face yellow, but then I right click on this one, this airfoil, and make the airfoil what? Basically blue, like that. Okay, and maybe this one another color too. So you can have a multicolor object if you choose to. If you do body, then the whole thing will be the same color. Okay, so that's about changing the color. Now also, you can make your object be transparent. Sometimes there is like internal structure, like as I mentioned for the wing. You have the skin of the wing. Also, you have what? You brought in your ribs and spars and you assembled the whole thing. We'll talk about assembly later. So now you want to show your wing, and not only you want to show the wing skin, you also want to show inside the wing that there is internal structure. So the only way to show inside it is if you make it transparent, right? So how can I change transparent? Instead of basic, you click on the advanced tab, and then you click on elimination. Okay, and here one of them, as you can see, it says transparency. It's 0, so it's completely opaque, but you can what? You can change and make this guy to be more transparent. Okay, so if there is anything now inside of it, you can see it, right? I can show you in another example also. Let me show you one other example, or let me open up something. Plate, maybe. All right, and let me just put it back to the gray color. So here we go. I right click on the part and then go to appearance, and under advanced illumination I make the part transparent. Don't know if you can see it or not, but now it looks like the part is now being made out of glass instead of solid object. Yes, so now if there is anything inside this, I should be able to see that, right? Like what? Let me show you. So I'll make this a little bigger. So this is kind of like that wireframe, right? So I make the part bigger, and now inside this, I'll create a cut. And let's say 1, then 1, or 2 and 2. Yes, so now there is a cut extrude inside the object, but now I can see it because the part is transparent. If it was not transparent, I could not see that, right? Just look here. I could not see it unless I put it in what? In wireframe, right? So this is what you have. There is a cut extrude, you cannot see it, but if I make it transparent, now I can see that. So this is about that. Then you can also, on the right hand side, you can apply texture. Okay, so this is the appearance that you have. You can have different appearances. You can have plastic appearance on the part, different textures. You can have metal appearance on the part. You can have aluminum, bronze, nickel, all sorts of metals. You can have glass appearance on the part with texture. Okay, so there are so many things. Now when you render it, you can see them. You can see the difference here. You cannot see them visibly, but I'll show you later. You can put fabric effects on it. This one probably you can see better. Okay, so there are lots of things that you can apply to the object and make it look a lot more interesting for rendering purposes, right? So now I guess you can see a fabric here. Okay, so that is about editing appearance, adding texture, adding color, make it transparent. You can also apply material, and then the appearance will be taken from the type of material that you have applied. And before I talk about that, let me actually talk about view setting. So view setting, I mentioned it, but I mentioned it one more time. This is where you can basically add different ways of rendering the part, whether in perspective or not, whether having shadow or not, whether cartoonizing it or not. So let me talk about that. I also want to talk about applying a scene, although I talked about it earlier, so let's talk about them very fast. So one, as I said, is you come here and it allows you to do shadow or not do shadow. Right now I have it. I check it, I don't have it. Then the ambient occlusion, it's not going to do much here because the effect of ambient light is not huge. Perspective puts the object in perspective for you. And cartoonizing makes it a little bit cartoonized. So this is for View setting, also with this one, you can apply a scene, right? So I click here, and then I apply a scene that I want. So there are some basic scenes that you can basically add, right? Or as I said, if you don't want any of these, then you go here and under manage favorites, then you go over the ones that exist and you can basically add them. If you check the mark next to them, then you're allowed to use them. Okay, so just choose anything that you want and okay that, and now it is accessible here. So that's editing appearance. Now, as you can see, all of these views are pre-made into SolidWorks. So you might say, what if I don't want any of these? Then I'll show you later when you want to render the part, you can add your own customized background picture if you don't want any of these. Okay, but anyways, the default of CATIA SolidWorks is 3-point faded, but you can add anything that you want. So I talked about those. Now let's talk about material and also talk about lights, cameras, measure, and mass properties, important things. So material. So sometimes you want to apply a physical material and then measure the mass of the part or other properties of the part based on the actual physical material. So right now you see under the tree it says material not specified, but I can specify that. So I right click here and then say what? Edit material. I can choose from some of these that are used all the time, like I can make it copper, right? Or I can say no, I want rubber, right? Or I want brass. Okay, so you can do that, or as I said, you go here and open up the library. SolidWorks has a very huge, good library. Okay, so if you look at SolidWorks material, you have all sorts of alloys of steel, right? You can apply stainless steel. You have all sorts of aluminums, irons, titanium, plastics, other alloys, then glass fibers, carbon fibers, silicon, so many other things. In non-metals, you have interesting things like glass, like water. Okay, that's really interesting. Then under plastics, you have a lot of 3D printing plastics like ABS, okay? And then PI or PET plastic, PET. So there are so many other plastics here too that exist, and you can apply any of them that you want. You can apply wood, right? All sorts of different wood. Let's say I want a pine wood, and I apply that, and now it is gonna appear with wood here, right? And now that it is made out of wood, now I can basically measure the mass of the part or anything else I want to, right? So when I come here and go under the Evaluate tab, if I click on mass properties, now these are calculated considering that this material is actually what? Pine wood. So this mass that you see, 43 pounds, okay, pound mass, this is considering that this object is made of wood. If you don't want the IPS system, you change it to MMGS, and now whatever you measure will be in gram and kilogram. So here, so that's the mass, it's 19 kilogram, right? That's the density of the material with 2 digits. It's more than that. That's the volume of the material. That's the total surface area. That's the location of the center of mass. And these are moments of inertia, principal and non-principal. Okay, so you will talk about all of this if you haven't already in your statics course. So calculating many of these are extremely hard if you want to do it on the paper by integrations, okay, double, triple integrations. So it's not really easy for many objects to calculate their moments of inertia or even center of mass. You'll see in your statics if you haven't already. But when you have the part in a CAD file, it's not going to be hard. The software will calculate that numerically for you. Okay, so this is really, really useful. And the coordinate with respect to which all of these numbers are measured is the default, which is basically centered at origin. Sometimes it is asking you to calculate the moments of inertia with respect to a reference frame other than the default XYZ. So let's say the center of it is here at this corner and the XYZ axes are different than this XYZ. The orientation is different. Then if there is such a coordinate frame, you go here and then it gives you another option other than default, and then you choose that coordinate frame, and then with respect to that, you will calculate everything, right? So just look at these numbers, keep them in mind, okay? 0.-17 and 253. Actually, let me take a picture of that. So these are measured with respect to what? This is the centroid of the object with respect to the default XYZ. Now here, I'm going to define a new coordinate frame and measure it again, recalculate it. So look. So for that, I need to first define a new coordinate frame. So I go back to features, I go to reference geometry and say, create a new coordinate system for me. It says, okay, where do you want to put the origin? I say, put the origin here. And then, do you want your x-axis to be parallel to the original x or different? I know I want it different. I want x to be parallel to this axis, actually. Then I want my y-axis to be this axis. Okay, actually, I guess I chose it parallel to edge 1, so I have to say this one. Okay, so you see now this is completely different than that. Look at the XYZ and this XYZ. They're oriented differently. The origin is different. And that guy, I call it what? Coordinate system 1. So now, if I evaluate my mass properties again, they are measured with respect to default, but now I can choose what? System 1, and now look at the numbers. Look at X, Y, and Z. See how much they are different from what they used to be. Yes, because my coordinate frame is different. Okay, my reference is different. So that is very important in many applications with respect to which system you are calculating your numbers. And I guess I just told you how to create a coordinate system, right? So before I get to this, maybe I need to add one more thing for you and say coordinate system, right? Customized coordinate system, and I'll add that to my slides. Then we'll talk about those measurements. Yeah, or maybe that's good. The other thing that you can measure, let's actually talk about it right now, is the measure command. This one is not for measuring mass or moment of inertia or centroid. This is for measuring distances and dimensions. This one here, that is like a measure tape. Okay, it's also can be found under the evaluate, and this one allows you to measure any quantity you want. Let's say I want to know the length of this edge. There we go, it's 609.6 mil. Or I want to know the distance between this point here, so allows you to click this point and then this point. What is this diagonal length? There we go. Not only it gives you the direct distance, it also gives you dx, dy, and dz. Okay, so it shows you whether the dz is 0 here. So it shows you also dx and dy. If they are not on the same plane, then you also have a dz, like this case. Okay, so you can measure the length of lines, you can measure the distance between points. If you click on a surface, it gives you the surface area and the perimeter of the surface. If you click on different surfaces, it gives you the distance between them. So here and here, what's the distance between them? It gives you a normal distance. Or you can do it between, let's say, an edge and a surface. You can do all of that too. Or a point and a surface. You can do all of that. If you click on an arc, it gives you basically the length of the arc. So it is a very, very good tool for measuring so many things, right? So here, let me make this visible. Sketch. Right, so now if I go here and click on this arc, you see it gives me the location of center and diameter. If it's a surface, then it gives me the surface area. So this is very, very useful thing, and it can give you a ton of information. Let me see. I want to show you one more thing. And if I select this edge and then this edge, it gives you a distance between them, right? But distance between two intersecting edges doesn't mean anything. So what it is really doing, it is choosing 2 points that I clicked on and showing those. But it should allow me ideally to measure the angle between the lines too. Okay, so let's see. That's where you can change the angle. Let me go to some sketch maybe. So if I have some sketch previously made, now of course I can just determine the angle myself, right? It's 50 point something degrees. Let's just make it 50. Let me get rid of this dimension now. Let's see if I can measure that for me, if it already exists. So this line and this line, right? So right now it is again giving me a distance which is meaningless. So there we go. So I first turn off point to point because that's not what I want. And now it is giving me what? An angle. So make sure the point to point option is turned off. Otherwise it is always looking into 2 points, right? So if I go back here, and again, I click on this one, I turn this one off. So if I select this edge and this edge, it should give me an angle. If it doesn't, like this, then you click here on create a, let's see if it allows me to, yeah, actually when you do that to create a sensor, here it gives you the angle in between. Okay, so it says what is it that you want to measure. You can add more, we'll talk about sensors later, but basically as you saw, I'm allowed here to be able to measure the angle as well. Okay, so that's also about measurement. Now I mentioned that you have a library, and this library has a ton of material that you can specify, you can remove, you can change. But right, so here the material is pine. I can right click on it and change it to something else like malleable iron, or I can remove the material, so I can make it without material. Now let's say one of the materials that I want to apply here does not exist in the library. So when I go here under plastics, okay, one of the plastic that is very common in 3D printing is called PLA, polylactic acid. Okay, the cheapest plastic in 3D printers, and that plastic is not there. It's quite weird. ABS and so many others are, but PLA does not exist here. So can I add a custom material and customize it myself and make it? Yes. You can even add stuff to the library, right? How? So first, start with a material that is quite similar to that plastic. So ABS and PLA are different plastics, but since they both printing plastics, I can choose that. Yes? First, copy a material to a custom library and then change the properties. Okay? And the other important thing is before you do all of that, you have to first right-click on custom material and then what? Create a new category. So if I come here, these are the custom material. This is where I can create something, right? So I right-click here and then say I want a new category and say what's that? I say 3D printing spools or plastics or filaments. So now I have a new category called 3D printing filaments. This is an empty folder right now, but I can go under plastics here and then copy something that is, at least the type is similar. Let's say PET or ABS, it doesn't matter. I right click and what? Copy it. Then I come here, right click and what? Paste it. So now this plastic is what? Under this folder. But now I can change it. Instead of PET, I call it what? PLA, and then the PLA or polylactic acid then I can provide what? The properties of this, right? So here you see the elastic modulus is this much. If that's not the case, I change it. What's the Poisson's ratio? What's the mass density? So if I don't have them, I'll just Google them and find them. Say PLA mechanical properties. Okay, and that should allow you to find some of the important thing about this plastic. Basically here you can see, and if you don't know about these, you'll find about them later when you go to your solid mechanics course. Okay, so 1.25 gram per cubic centimeters. So that's where the mass density is. This is based on kilogram. That's fine. So you have to per meter cubed, so you have to convert, right? You have to convert 1.25 gram kilogram. So you have to multiply that by 1,000. So it's going to be 1250. What is the Poisson's ratio? What is the tensile strength in Pascal? So here you see the tensile strength is 53 megapascal. So you come here and then here, this is almost 53.2, right? So 6 zeros. Yes, and then compressive strength if you have it, if you have a yield strength, anything, if you have the Poisson ratio. So for these, you have to know solid mechanics to know what I'm talking about. But you can find all of these mechanical properties from basically credible sources. And this is ResearchGate, so it is coming from a paper. And then Young modulus and so many other things. And once you have that material, now you apply and close it. So now in my library, I also have PLA and I can apply it, okay? You can talk about its appearance, right? There are so many things that you can do about this material. So this is about, and you can see it here too, okay, how it might look like. So you can add a customized material here, and I guess I also talked about mass properties and measure. The last thing I want to talk about finally is modifying the light and the camera for rendering. Okay, so lights, although I can talk about these later too, but let me talk a little bit about it here. And let me not talk about cameras because we are not doing the rendering right now. So later in one of our future lectures, we're going to talk about, maybe I talk about decals too, but again, in one of our future lectures, which is here on PhotoView 360, this guy, we'll talk about all of the appearances again. So I'll just briefly show you how to change the lighting of the scene, but the goal is here really not to get into a lot of depth of that. So if you go here on this command manager, feature manager, command manager, and go to display manager, there are 3 tabs: appearance, which you went through, and then what? Decals. And we'll talk about it. Decals are basically like the logos, shapes of the basically, yeah, the best word is logos of companies. And then here under view scene and light and camera, you can modify. So you can change your scene, you can change the camera. There is some amazing thing called walkthrough. I'll talk about that in that lecture. Under lights, that's where you can see the lights available. So you have an ambient light, you have 2 directional lights. Right now they are invisible, but if you right click on them and say show in SolidWorks, then you can see them. Okay, directional light 5 and 6. And basically, if you want, you can right click on them and say edit them. Okay, and now you can move their position with respect to the object. You can change their brightness, so you can make the light to be way brighter or darker. You can change specularity reflection. You can even change the color of the light. You don't necessarily want the color of the light to be what? White. Okay, so you edit that, and then you can come over this one and edit this one too, right? And let's make this one blue. It's going to be interesting, right? Because when you basically shine blue and yellow, you're going to get green, right? And then you can move this guy, of course, right? So you create a gradient of color here. You can add more if you want. Okay, you right click here and say what? Add another directional light, and then put it wherever you want. And edit the color of that as well. Right, just look at this. And then there is an ambient light, which is uniform. You can turn it off if you want. You can turn it on. You can make it brighter, right? You can modify it. Okay, and then as I said, you can add shadows and make it more realistic. So there is a lot of things, and when you don't want your light, just right click and say do not show them. Okay, so here I did not really change the colors, I changed the lights, the color of the faces. I changed the color of the light sources, and I got this quite interesting shape here.